Hello everyone. Previously we had discussed on the topic sliding window, right? So we have discussed on the sliding window algorithm, right? So today we'll be discussing on the topic this one, two pointers algorithm, right? So let's get into the definition part first. So the two pointers technique uses two indices, right? So just keep this in mind. Simple. The two pointers technique uses two indices that move through a sequence to solve the problems more efficiently, often in linear time, right? So again, the two pointer technique uses two indices that move through a sequence to solve problems more efficiently, often in linear time, right? So typically pointers either start at opposite ends or move in the same directions, right? So either the pointers start at opposite ends or it can move in the same direction. Just keep this in mind. Again, I'll just read this one out loud. Just listen to this. The two pointers technique uses two indices that move through a sequence to solve problems more efficiently, often in linear time. Typically, pointers either start at opposite ends or move in the same direction. Just keep this in mind, man. Right? Let's discuss some of the important points as well, and then we can move into the example part. So here, two pointers shine when our data has structure. Means when they are sorted, when the data is sorted, usually when the elements are sorted, basically, right? So the common patterns are opposite ends as well as the same direction. So this one we have already discussed this one in the definition, right? Typically pointers either start at the opposite ends or move in the same direction. First let's discuss the opposite ends. So first, two pointers, see here, we will start L at the beginning. L and R are left and right pointer, right? So L will start L at the beginning and R at the end, right? Suppose if we have six elements within the array, so the element, the first element that is present at the zero index will be this one. What do we call L? We will point that one to the L, and the element that is present at the fifth index or the uh, length sixth one, right? So that one we will be considering as R. Opposite ends we are considering, right? So we will move the inward uh, based on the condition. So we will move them inward based on a particular condition, right? So example, when sum is too small, basically will move L. When sum too big, will move R, right? So this is just for the example sake. So let's consider one beautiful example, and then I'll understand. Then let's try to understand the same, right? So now let's go with the same direction. Same direction means slow and fast pointers. So here when I say slow or fast pointers, we'll be making use of the slow pointer to build or track results and a fast pointer to scan, right? So when I say this, so basically for removing the duplicates or the partitioning purpose, we'll be making use of this one, right? Slow and fast pointers. So why it is good? Usually we can run this one in big of n time and big of one extra space, usually for the memory, right? So and if we sort first, we might lose original indices unless we keep the value index pairs, right? So just keep this in mind as well. This is one of the thing I found, this one I wanted to explain basically, right? So these are some of the points I found, this one to explain basically, right? So now we are good uh, to get into the example part basically. Let's consider beautiful example here. So I'll just go with when the this one, when two sum is sorted. So I'll just consider this one, function name two sum, this one sorted. Let me pass the parameter a and t. So this is fine. Let me assign a L to 0, left to 0, right to the last one, nothing but length of a minus 1. So this is fine. What happened here? This is fine, man. So we are considering the left pointer that starts at the beginning, and we also considered the right pointer that starts at the end, right? So this one I have considered this two sum sorted, whatever name I have given. So a is sorted here in this case, right? So this a, I'm speaking of parameter, a is sorted list, right? And t is nothing but the target sum, right? So just keep this in mind. We are just going with a simple example here. So let me go with a while loop here. While, so Python, right? So while left less than right, then we have to go with the current sum of the two pointed values. When I say current sum of two pointed values, I'll just go with the simple if condition here. If s equals t, then what I'll do, let me return L comma R. So this is fine. Now if s is less than t, meaning here we are considering if the sum is too small, we have to move the left pointer right. So that's what we'll be doing now. First, if the sum matches the target, then we are returning the indices here, this one, line number 20. Now what we need to do, so what error we have here, s is not defined. Oh, I have not defined s at all, thank god. So this is fine, just give me a second here. Let me assign the s to a of l plus a of r. So this is fine. So we are just going with the current sum of two pointed values here, right? So now if the sum matches target, we are returning the indices, this one, basically 21 and 22. First condition, if sum matches target, then we are returning indices. If the sum is too small, then we have to move the left pointer to right. So that let's write for that one. If sum is small, or if sum is smaller than the target, then we have to move the left pointer. So L equals L plus 1. Simple. Else if the sum is too large, then we have to move the right pointer to left, right? So how can I write that one? I'll just go with the else. Now r equals r minus 1. So this is fine. Let me go with a return value. So return, this one will be minus 1 comma minus 1, meaning no valid pair found, right? So we are done with this part, man. So let's go with the demo or the example usage. So I'll just consider some random array here. So this one, I'll just consider some values 1, 2, and let me go with 4, some random number 7, 11. This is fine, man. So this is sorted, you can clearly see, right? So minus 2 is the smallest, and then we are going with 1, 2, 4, 7, 11, right? Sorted array based on the this one code we have written. So now let's consider the target sum. I'll just go with the capital T. Let me assign this one to the value 9. And now let's run the algorithm. Basically, I'll just go with index equals, let me go with to some sorted function, right? So we have to pass array as well as the target, right? So this is fine. Now let's show the input array. So let me go with print here. So this one will be array. This is fine. Also let me pass array. This is also fine. Now let me go with print again. Now this time let's show the target. So this one will be target, capital T. This is fine. Now let's show the found indices, nothing but we have to show the indices that we have found, or we have to print the minus one, right? So I'll just go with uh, print. So this one will be pair indices we are showing, right? So along with that, so this one I have to write within the string, sorry. This is fine. Now let me pass index here. This one is fine. ID, where we are making use of, why it was showing ID. This is fine. Index. So now or else we have to show minus one, right? So if index not equal to minus 1 comma minus 1, so then we have to show the pair, nothing but I comma j equals, let me assign this one to the index. The final one here would be, so let me print something for the interactive purpose. So let's go with the pair values here, pair values. So this is fine. Let me go with array of I as well as the array of j. This is fine. Yep, we are done with the coding part. So let me format the code once, man. This is fine. Yep. Now if I run this one, what is the output that we need to get here as? First we are displaying the array, right? So we are just displaying the array. See here. Where is this one? we are just printing the array here, right? Line number 33. In the line number 34, we are just printing the target, right? So first we have to get this array, and then we have to get the target 9. Then we have to get the paired indices basically, right? So basically what we are doing here, uh, pair indices, this one, the algorithm has to find the positions, right? So here in this case, we will get 2 and 4. 2 and 4, because see here, 0 1 2, we have 2, this one 2 and 7 is the answer, right? So basically 2 and 7 will lead to the target 9, right? So when we sum up 2 and 7, this one has to lead to the 9. We are going with a sorted 2 sum, right? So addition of the two elements has to lead to the target. So here in this case, see, this one is at the index 2, 0 index, right? 0 1 2, and 7 is at the index 4. So we have to get the output here for this one, print paired index indices along with the index. So this one we have to get 2 comma 4, and paired values, see here, if index is not equal to minus 1, then what we are printing, we are printing the values basically. Paired values are this one basically. Now we are not printing the this one indices, instead we are printing the values, right? So we just have to print 2 as well as the 7. So we are going with array of I and array of j values itself directly, right? 2 and 7 we have to get the output. Basically first we have to get the array, we are printing the array, next we are printing the target, next we are printing the this one indices, nothing but here in this case this one 2 and 4, and the finally we are printing the values, nothing but 2 and 7. So this is the output that we need to get, right? So let's check the same thing. I'll just go with Python. So let me right click, let me copy this one, let me paste it over here, dot py. So here, see the same thing. So we are getting the output wrong here, 0 comma 5, why? Minus 2 comma 11 pair values. Oh yeah, minus 2 comma 11 will also lead us to the 9, right? So now, yeah, I forgot this one. We are having the multiple valid arrays, man. So this one also, minus 2 and 11 also works basically. It will lead to the target 9 itself, right? So you can just go with a 0 comma 5 as well. So I saw this one basically 2 and 7 will lead to the 9. So that is the reason I considered, and minus 2 I have given 11. So this will also, this also works basically. The first valid pair that we find here itself, uh, the first valid pair that we find here is minus 2 and 11 itself, rather than 2 and 7, right? So let's consider this one itself, right? So 0 comma 5 and minus 2 comma 11. So this is also perfect. This also works correctly. We have multiple valid pairs here, so this is fine. So this is it for the two pointers algorithm, simple one, right? So I hope the solution part is completely clear, man. This one algorithm part is completely clear, man. Let me summarize whatever we have learned so far, right? So just give me a second, 1 second here. uh, just keep these things in the mind basically, right? So two pointers reduce many search or scan problems to what, to big of n with a big of one space, right? So this is one of the biggest pro of using the two pointers, and we'll be making use of the opposite ends for the problems on sorted data where moving left or right changes the sum or order meaningfully. Just keep this in mind as well. So we will use the same direction, nothing but slow or fast when building results while scanning, right? So this also just keep this in mind. Example, we can consider dedupe or the partition, right? So uh, final one is, we have to always check preconditions. When I say preconditions, whether it may be sorting, and we have to be extremely careful to preserve original indices if needed, right? So these are some of the important points that we need to consider. So I just wanted to summarize this one, right? So now we are done with the two pointers algorithm, right? So we are done with the two pointers algorithm. Next we'll be discussing on the topic or the algorithm, this one, Dutch national flag algorithm, right? So for now, this is it. Thanks for watching, guys.